second and final presentation as a tag team. Let's see, Travis, Christian, Jessica, and Viviane talking about FindStat.
Yeah, thank you very much, and thanks to everyone for staying long enough. We gave a presentation on FindStat 2 years ago at FPSAC, and I think we had many people afterwards looking at it and playing with it, and I think it was really nice. In particular, we got these three guys starting to work on FindStat, which really improved the situation quite a bit. So I want to give you an update for those who have not seen the talk 2 years ago, which are quite some here, I guess. I want to quickly define the objects we just want to discuss. So we want to quickly define the objects we discuss, and then we start showing you how the game goes and how you can use FindStat for your research. So the first question is, what is FindStat? Can you press some button? So, a statistic, so a combinatorial statistic we've already seen quite some, is we start with a combinatorial set, whatever that might be. For us, that's now basically any set. It can be a set of permutations, of partitions, of set partitions, of set compositions, of integer compositions, these kind of combinatorial objects we are talking about. And a statistic is a map that takes such an object and turns it into an integer. And the idea of FindStat is Sloan is really doing a great job for many people. For I guess most of you have used Sloan, so the OEIS at some point. And we thought we want to do the same thing for combinatorial collections, combinatorial objects. And we want to use the much more structure that's in these objects automatically. So we want to not only study combinatorial objects and their statistics, but we also want to study maps between all these combinatorial objects and then apply statistics. So we want to not compute all these maps and all these statistics by hand every time we want to find some nice patterns and some nice structures, but we want to have the computer doing that for us. So that's the main idea. One example, no? The example on the bottom? Okay, I guess most of you know what kind of examples we are looking at, but here's like, we start with a set of permutations, which is like graded by the length of the permutation. So this takes a permutation and sends it to the number of inversions of that permutation. We've seen this statistic earlier, and we've also seen maps on permutations earlier. And now, Viviane is now going to show you how the game is played. So this is like the front page of the website, which you can find up there, FindStat.org. So if ever anyone want to use a computer and play with it, go for it.
So let's start with a use case. In your work, you come up with a statistic. So what does it mean? Like, let's say, for example, you come up with some polynomials, and you know they're indexed by permutations, and you have some coefficients attached to these polynomials, and you don't know what they are, and you want to know, maybe somebody else came up with the same things, and you want to see. So you go to FindStat, and you want to see if you're, here it is. So you want to see if you want to look for your statistic into FindStat. So what do? You go there, and you go to the statistic finder thing. Okay. And so now you have like a bunch of objects, combinatorial objects that are in FindStat. Yeah. And the one you have is on permutation. You click permutation there. Okay. And now, so you have your statistic, let's say, for permutations of size 2 and size 3. So yeah, it's a bit like that. So let's say your statistic is, okay, this is 0, then this is 1, then here you have a 0, here you have a 1, here 1, here 2, 2, and a 3. So maybe you're really new into combinatory and you don't know what this is. So you go to FindStat, and also maybe you're not combinatorial people and you've never seen this. That happens, you know. And so you put your numbers and you click search the database. And here, wait for the database search. Oh, there is even like a sound effect.
Why is the parking functions is a title bar.
That's because I recently looked at that page.
Ah.
That's just
So
your
you'll see
history
it in a
of
minute.
pages.
It was slightly faster earlier.
Yeah, here it
Yeah.
is. Yeah, the other one we pre-computed it. So here you see that the statistic you were looking for was a statistic on permutation. It's the number of inversions. Wow, what a surprise! Okay, so but you have more than this. Like if you go like just here, what this is? No, I didn't want to do this.
Apparently hit Control-Shift-C, so you're seeing the web page.
Oh.
Look at the guts of the web page.
Okay, so you see here that it also says it's this statistic under the major index, inversion number to major index corresponds to the major index. This is a map we saw earlier this morning in the talk of Andrew Wilson, I think. So not only does it look in your database about statistic on permutation, but it also like apply maps like to your permutation and see there are all the statistics that you can obtain this way. So it tells you like there is a map on permutation themselves and you obtain another statistic here. And if we continue there, you'll see that there are also maps from permutations to other objects like alternating sign matrices, and the statistic on permutation corresponds to something on alternating sign matrix. So here it is, for example, it's a number of inversion number, so it makes sense. And there, like, you can apply multiple maps, and you arrive into other objects, and you have like a bunch of those, as you can see, because of course it's an inversion number, so it appears everywhere.
Is it applying a bunch of known maps like on the fly, or is it the second that here there's inversion numbers? It said, oh, yes, I have saved the Berg's map from my information.
Can I repeat this?
So if I give it a set of permutations and it's not connected to something as nice as inversions, it just has a bunch of maps it tries on everything.
Yes.
Like, no matter
I
what.
mean, it's-
Yeah, no
everything
matter
on the
what,
fly.
like we have a bunch of maps on permutation. It applies on all, like if you give it permutations with number, it will apply all the maps we have and see if it corresponds to a statistic on like either permutation or all other objects.
Is there a place to look up what maps?
Yeah, I'm coming to this.
Fantastic.
Can you make it smaller?
Bigger.
Okay, so what are the statistics first? Here we go on statistic database, and now you have a list of all our statistics on different objects. So we can look for the one we had just there. So permutations, and here you have the number of inversion, it's over there. You can click on it, and here you will have like, so the statistic itself, the reference, and sometimes more explanations. And so here you have also a bunch of buttons that you can click. So search for values, I can click on this, it's going to give actually the same. So I click on it, but I don't wait for the result. I go to the next page where I already computed it. And it's actually the same thing as what we already did. Like it automatically takes your objects and search them into the database, like without you copying and pasting into the Finder itself. Why is there this button? Because, so I said use cases, you find a statistic on your work and you want to test if it's already there. But there is another use case, which is really, really common among combinatorials, is that you love your objects and you want to play with them. That's how I work. So you have an object that you really like, and you want to see all the statistics that are on this object, and you want for each statistic you want to click, search the values to see how it's related to other objects, and how you can like link the dots, like what are the algorithms, and maybe there is a map that you didn't know about and you want to know what it is, etc. So here's a search values button, and so what then I do, I guess the search distribution one. Oh, this is a result.
Oh, that's the graph.
Oh yeah, that's a graph of maps, by the way. So
Is that project generated? Or is this by hand?
it's generated. The maps are actually into Sage, and so this we have a way to all take them and put this in the graph. So here you see the vertices are the objects that we have, and all. What no?
That was the browser, though.
Yes.
Yeah, that was a browser where we had all the pre-computed tags
Now you know
for
our
the
town.
presentation.
We're
Click restore, click restore.
What do I click?
Go back.
Yes.
Press escape.
Oh, James, do it, please.
Oh, hey, that's great.
Okay, so thank you.
No?
Oh,
Yeah. So you've seen the graph? Okay. So that's the idea, that you really try to understand the links between all your different objects and all the different statistics and stuff. And now I go back to this permutation statistic, and I will look at the other button, and I will look at the second button here, which is search for distribution. So here is another use case, is now you have a statistic coming up in your work, but you don't know exactly what number is associated to what object. Like you have the list of permutation of size 3 on the left, and on the right you have a list of numbers. And you know you want to put like arrows in between, but you don't know exactly how. This is the idea of the search for distribution one. Like we saw this morning the map between the inversion number and the MAJ number. You saw that the map was not that easy. Sometimes maybe you come up with a statistic that has the same distribution as another one, but you still don't have the explicit map between them, and you still want to know that they are related somehow, and because you want to see that as an open question to solve. So what you do is you click search for distribution here, and now it will look at all the statistics that have the same distribution, and I had computed this, and it's here. No, it's yeah, because I had computed it before, but then because we restored everything, now it's going to search for a while. But anyway, once it's going to find the results, I've looked at it so I can tell you what it is. It's going to find the MAJ index, because we were on the inversion number, and so the first result that's come up will be the MAJ, but not after applying the map, because here it doesn't know yet about the map between inversion number and MAJ. It's just going to see that it's the same distribution, so it's going to tell me MAJ and also inversions and all the things that are the same distribution as the inversion number. And it's doing like, so you have a search distribution button on your statistic object, but there is more, like you can also directly search for the distribution into the statistic finder. Like I won't show you
Can you show
now.
it quickly?
You want to show it?
Yes.
Yeah. Yeah, sure. Like I go to statistic finder, and no, yeah, because
it's confusing.
yeah. I go back to statistic finder. We need to scale this. Yeah, let's do that.
You just click on the finder.
Well, yeah, you did.
You would click, but it seems to be like, oh, here it's back. Finder. Maybe the statistic finder page is somehow saved now. That's possible. Oh no, it's there. So let's, wait, it's doing this. Permutations. Okay. It's a bit slow now, I think. I think it didn't like what happened earlier. We still have issue with this being slow thing. We're really trying to fix it.
I mean, the problem is there are now so many statistics and so many maps that
Yeah,
it's
it
getting
worked
really
fine at the beginning
big
when
problem.
it was not useful, but now that it's not. So here, see, I have the statistics. I have it. So let me. So here I have a box like distribution, and it doesn't show well on the screen. But the idea now is that you could put your numbers, and they will correspond. Like you would put your numbers, but they won't be directly linked. Like each number won't be. Oh, here it's better. Like this. So see now it says that you could put 2 numbers for 1221 and 6 numbers for the permutation of size 3, but it doesn't say that each number will correspond to exactly one permutation. It's real, like look for the distribution itself. And by default, the distribution box is associating like all the numbers of a given size to a given set, but actually, if you go to the free box, which is here, you can enter your data like as a text thing. And if you do this, you can do some more like advanced thing. Like for example, you know your statistic for the identity. You know which one it is. Usually you do. And it's just the other ones that you don't know how they fit. So you can tell, okay, the identity is 0. I know this. Just tell me if something has 0 for the identity and something else, and the distribution for the others. So you can really like really explain exactly what's your problem to the machine, and then it's going to look for a statistic that's matching. So let's look at the other patterns on the statistic page. Do we have statistic page? Okay, so let's go back to this statistic database, and let's pick a. Yeah, that's good. Let's just open and show you a bit all the other things you can do with your statistic. Looks like it's starting to be really slow now. I think it has this tendency of becoming slow whenever we want to do a combination. I think the server like knows what we're doing. Here. Yeah. I don't know. Let's take another maybe on communication. Let's change. Yeah, it's I don't know. I think it didn't like the fact that we ran all the search all together, all at the same time.
There you go.
Yeah. So here, and so I showed you like search for value, search for distribution. You have a nice like Caesar generating function. So that's actually what it's looking for when you do search for distribution. But now you can see it like as a nice polynomial. And you could look at, you can search for the OEIS to see if your statistic is in there. So you click there and it will.
Distribution is in there.
What?
The distribution is in there.
Yeah, if the distribution is in there.
Usually that's fast, so maybe OER
Yeah,
is
that's not us. The fact that it's slow, that's the OEIS, that's not us. Or the internet here. So here you find it, and it has found something.
I'm going to blame the internet that way. That FindStat's slow because the internet's slow here.
Of course, it's always the reason. Of course. So I think I showed you everything that I wanted to show you on the demo. Yeah, and this is yours. So now I will let Jessica finish like with all the stuff you can do with FindStat, especially working with students.
Yeah, thanks, Viviane. All right, so hopefully these slides will work. So how can I contribute, which is hopefully what I'm wanting to ask right now. So there's kind of two things we can contribute with research and with teaching. And so the research that I wanted to show you did involve the website. So let's see if that goes. So, you know, if you want to contribute, then you'll be on our list of contributors, which would be really cool, which is right now. And we also have a lovely citations tab right there, which also isn't working. But, there it is. Okay, so we're really happy to have some citations, especially this one on the bottom I wanted to advertise was Joel Lewis and Alejandro Morales' paper, and in their paper, which I had it at the end, they say something very nice right here. They say they obtained the first evidence of theorem 2.1 from using FindStat. So the things you can do with FindStat is you can play, right? You can play with statistics, find new connections, and maybe even write a paper. So, and then another thing that I wanted to show you from, not that one. No, not that. The other thing I wanted to say was that, right here. So, we have this fingerprint database for theorems. And some of you may have seen at Stanley Fest a picture. A slide sort of like that. I guess that's kind of hard to see, but this is a slide from that Travis took from Bridget Tenner's presentation where she was talking about fingerprint databases for theorems. So one other reason to put your so suppose you have a statistic that relates to your research and you really care about it. It's a good idea to put it in FindStat because there, other people can find it and they might email you about it, and that would be fun. I've had some of these fun conversations, and it Levin's talk about parking functions where she mentioned lots of statistics. So that made me think of telling you about how you can use FindStat in your teaching. So I just wanted the very last thing we'll tell you about is a project that I did with I was teaching an undergraduate combinatorics class, like I'm sure many of you do. And so I gave them a group project to pick a combinatorial collection here from the list, and then add statistics to the database and add content to our wiki. So there is a FindStat wiki, which we haven't talked too much about, but it is a great place to have a lot of information about various combinatorial objects and statistics. So if this works, I would like to show you the parking functions wiki, which was created by two of my students who had just learned about parking functions, the week before. So this, bear in mind that this was made by undergraduates, but I was pretty happy with what they were able to do. So they even made this lovely graphic of the cars parking. That's pretty cool. And so they learned a lot of different properties. They even put the shuffle conjecture in, and I gave them some slides of analytics from Banff. And I said, put in a sentence about it if you can. And they're like, we can't put in a sentence. But they typeset it very nicely. So if anybody who actually works on parking functions would like to come and edit the wiki and tell us what the shuffle conjecture is really about, feel free. But this shows all the different statistics and the link to the statistic page on parking functions, and some more pretty pictures and some maps. So they're actually implemented a lot of maps on parking functions. And yeah, I think that's it. So that was something that students created from scratch. And I'm a big fan of projects for student learning in general, but I feel like the students really latched onto this project because they knew that what they were doing might actually be seen by somebody else in the world. And I thought that was really cool. So I think, there's one more thing. So I left the project requirements rather vague. And some people came up with some very interesting things. Those are both at the end. Let's see if I can get it to go in the middle. Anyway, I had one group, the Gelfand-Zetlin patterns group, come up with the idea to make a video about how to do the bijection between Gelfand-Zetlin patterns and semi-standard Young tableau. And I guess maybe I'll move this forward. But anyway, so it's a 5-minute video on how to do this bijection. And I think it's a really great explanation, and an explanation in a medium that people like and that doesn't appear on the internet anywhere else. They search for such things. That's about all I had to say about the teaching aspects of FindStat, except to say that it's actually really easy to use and really easy to contribute to, as evidenced by the fact that my students were able to do it. So there's a link to this video on the Gelfand-Zetlin patterns wiki on FindStat, and I think that's about all we had to say. So thank you very much.
Questions for the team?
So can you call this directly from Sage and or run it locally?
No and no.
But that text box, can you just type Python into it?
Yes.
What
Okay.
text box?
Which one?
The free box? There are several boxes where you can type in Sage code and have it run and produce the output that you need, and then you could paste that in and contribute your statistic.
Jerry?
So what I'm wondering, and I guess I already mentioned this to you briefly, but you have this whole diagram of different maps between different combinatorial classes, and the graph is very messy, and probably there is no good way to get it on paper. So I'm wondering, how good do you have a good system for playing around with the graph, not just the statistic from the graph, but the maps themselves?
Not yet, but it's part of what we want to do, and it's possible that it's not something that should be in FindStat, but more into Sage, I would say. Christian, I don't know what you think that is.
No, I think it's a good idea at some point to have what you want is you would want to just take permutations and see where it goes in the graph.
What I ideally want to is, instead of defining a statistic, I define a new map, and I want to tell the program which triangles or squares in the diagram now commute with my map. And of course, experimented it by checking.
We did that in the beginning, and that was computationally almost impossible. At least the ideas we had. But I'm very open to discuss that again.
It's just what you're doing, except that the map doesn't go to Z like a statistic does, but goes to another class.
Yeah.
Well, Daria, if you would like to help, let us know.
If I'm able to know.
Oh, you're certainly able to.
Yeah.
Any other questions?
Where is it running? Where's the server?
Currently it's in Montreal. So Chris Berg and I were starting that project in Montreal a few years ago. And it's still hosted by Atlassian. So François Bergeron is there, maybe not anymore. So he's hosting.
Are there plans for putting in our bigger machine?
Yes.
Yes. I mean this is almost finished, but I don't the problems we have with the program itself, I don't think it's not really helping if we use a better machine.
It's just
So I
because
think we
like
have to solve some deeper issues to make it really fast. But I think, I mean, if you typed it in for 7 minutes, I think it's okay to wait a few minutes for now. So it's not that you wait forever.
How many of the team are now working at Google?
Only one.
Only Chris.
So
Only
far.
Chris. None of us have any intention of working at Google at the moment, I think. I can talk for myself, and I think Travis told me he wasn't applying right now.
I'm not planning to right now. we'll see in a
So I
couple
think
months.
it's more dangerous to work on quasi-symmetric functions than on FindStat.